And on to question 4. The times that 48 trains left the station on Monday were recorded. The cumulative frequency graph gives information about the numbers of minutes the trains were delayed, correct to the nearest minute. The shortest delay was 0 minutes, the longest delay was 42 minutes. On the grid below, draw a box plot for the information about delays on Monday. So there are 5 things you need to know for a box plot. You need to know your shortest value, which is 0 minutes. I'll do a small line there. You need to know your first quartile. Now there are 48 data points in total, so that would be my 12th data point. Obviously you can do this a bit nicer than me using a ruler, but that's at 4 minutes. 1, 2, 3, 4, and that's going to be a larger bar. Then my median value, so 48 data points, that's my 24th data point, which is at 10 minutes. So I draw another large bar there. Then my upper quartile, so that would be at 24 plus 12, my 36th data point. 1, 2, 3, 4, 5, 6. As such, which is at 20 minutes. There you go, 20 minutes. And then I need my extreme point, which is at 42 minutes. And I'm going to do that with a much smaller bar. And then I join my lowest and highest points just using a horizontal line, and I connect my lower, median and upper quartiles in a box to derive my box plot. That's a nice simple 3 marks, I think you'll agree. 48 trains left the station on Tuesday. The box plot shows information about the delays on Tuesday. And then you're asked in part B to compare the distribution of the delays on Monday with the distribution of the delays on Tuesday. So, just like before, just like before, when I see distribution, I'm thinking, okay, so I can talk about my median, I can talk about my range, I can talk about my interquartile range. And this is only worth 2 marks, so in fact I only have to do that for 2 of them, but I'm going to do it for all 3 verbally at least. It's also worth pointing out that you must talk about this in context, so in terms of your delays. So, one thing you could write is that the median delay on Monday is longer than the median delay on Tuesday. Another thing you could write is that the interquartile range on Monday is equal to 20 subtract 4, so 16, and the interquartile range on Tuesday is equal to, what's that, 15, 17 subtract 6, so is equal to 11, and therefore your interquartile range on Tuesday is less than the interquartile range on Monday, and so bigger spread of times on Monday. You could do the same with the range, and just by looking at the box plots you can see the range of A is much larger than, range of Monday, is much larger than the range of Tuesday, so once again, much more spread out times on the Monday than on the Tuesday. Part C, Mary says the longest delay on Tuesday was 33 minutes. This means that there must be some delays of between 25 and 30 minutes. Is Mary right? So thinking about that on this box plot here, Tuesday, between 25 and 30 minutes is here to here. Now it's important to note that on a box plot, we know where our defining data points are, our quartiles, our median, our extremes of our data points, but we don't know anything about our distribution of the data points. So I know there are 25% of data points between my upper quartile 17 and my extreme value 33, but I don't know where they are. So Mary is not right, and she's not right because all of my data points could be outside of that range. So all of my data points in the top 25% could be between 17, was that delay, and 25, and then between 30 and 33. And actually I'll just change those equalities so they're not inclusive. So some explanation there. She's not right because we don't know where the data points are distributed, so they could all be outside of 25 and 30. And that's 6 marks sorted.